Hi. All right. Thanks everybody for coming. Today we want to talk about using a standalone Cinder service as a provisioner for Kubernetes. So first I'm just going to kind of run through some things about Cinder and some of the options that you have to run it these days. And then we're going to go ahead and switch gears and talk about the provisioner, how that works. And then we'll just do a little wrap up. My name is John Griffith. I work with NetApp. And this is
Huamin Chen for Red Hat.
So we've been working on this together for a little bit with a lot of help from the communities, both in Cinder and in the Kubernetes space. Adam Litke, big shout out to him. But anyway, on the Cinder side, what we kind of set out to do is, first off, come up with an easy way to run Cinder just by itself as a standalone service. So inside of the Cinder repo, we now have a thing called Blockbox that will let you use a Docker Compose file to deploy a Cinder service using Docker Compose. So you don't need Keystone, you don't need Nova or any of those other things. So you can truly run this in about 5 minutes and have Cinder deployed and ready to go. And then from that point, we can go and we can now plug that into a Kubernetes deployment and do dynamic provisioning and allocation of storage from that Cinder service that we made with Kubernetes. So
there you go.
Which one is it?
This one. Yeah. Back.
There we go.
Oh, just push it. Just roll it. Yeah, the back seat just literally roll it. All right. Just roll back and forward. Yeah. All right. Okay.
There we go. All right.
Yeah.
So a little bit of background on the Kubernetes side, for those of you that are familiar with it. There's a number of options that are available today in the Kubernetes repos. You can use the cloud providers, AWS, EBS, of course, OpenStack and Cinder, vSphere. And then you also do have some independent block storage plugins that are built in for iSCSI and Ceph, Scale.io, things like that. The cloud storage providers actually give us the bulk of what we want to do here. But the problem there is it's built specifically for deploying against Nova instances or Nova servers, right? So the idea of what we wanted to do here was actually turn this around and let you use Cinder against bare metal servers. So that was kind of the whole idea. The features that we're talking about here are dynamic provisioning, the ability to attach and detach, resize, do snapshots, so on and so forth. One of the great things about this, too, is you also get the ability, all of the capabilities that you have in Cinder, you by default end up getting them inside of Kubernetes now through the use of volume types. So do you want to take this section?
Sure. All right, I think this is something a lot of us have already seen before. So how the Kubernetes works, how the storage works, in particular in this case, Cinder. So we have the Kubernetes controllers. One of those is just responsible for the volume attach and detach, just like the way we are used to the volumes attach and detach in OpenStack, in Nova. So what happens here is that once the volumes becomes available in Cinder, the controller, which is running on the controller master, just issue the Cinder API call to attach the volume to the Nova host. And then from that point, the VMs get the volumes and presents to the VMs, and the VMs magically see the block volumes appears and do some probing to make sure this volume is the one that it wants. And from that point, you can mount the volumes and use it for whatever purpose inside your container. So John probably has better ideas already. She's already introduced the Cinder box inside the OpenStack volumes. So
Yep.
I'll hand this over to John.
Okay. We're just going to keep swapping back and forth here. So the idea behind this is in the Kubernetes space in particular, if you look at it, there's a lot of us storage vendors that have been around working in Cinder for a while. And what happened is Kubernetes came along, and it's a big deal. And so everybody's off now racing to try and do storage plugins for Kubernetes, which is great. That's awesome. But some of us had this idea of, hey, we've already invested quite a bit in this Cinder thing, and it works pretty well. We've gotten the bugs worked out. And, there's over 80 drivers in there that you can use that are supported. So what if we just actually wrote a specific driver and just used Cinder and reused all of our investment and hard work that we've already done, right? So that's what we've been working on. Some of the advantages that you get with that is because if you're an upstream Cinder product, you're getting CI, right? So you have all the drivers inside of Cinder are required to run a continuous integration test. So there's a lot of testing. There's a lot of things that go on there. And then, in turn, on the Kubernetes side, when you have a Cinder plugin, you can do a CI upstream on that as well. So you get a lot better quality that way. So there's a lot of advantages there. And then the other big thing is, in the past, people had complained, one of the things about OpenStack and OpenStack services is they can be difficult to deploy. They can be a little bit tricky. So what we did is we created a sub-repo or a subdirectory inside of the Cinder repo that does all of the work for you to containerize and deploy Cinder in containers, in Docker containers. So we've kind of got it almost to the point now where there's really no excuses anymore. It's super simple, incredibly easy. The code on the Kubernetes side, which we'll talk about more in a minute, is now in Incubator. And it's pretty good. It works pretty well. There's a few things missing that we're still working on, but I think it'll be pretty soon. We'll have it upstream in the main Kubernetes repo. One of the things that you have here is you have a couple of options. When you do the standalone Cinder, you can do it truly standalone, as in nothing except for Cinder, which means you use the Knowoff plugin. So there's no Keystone, there's no credential checking or anything like that. You just use login and password. You can also go ahead and deploy it with Keystone as well if you want and get a true auth system, which is probably the better way to do it right now. But you can see here, if you go to these GitHub repos here, you can get the standalone Kubernetes plugin as well as the Blockbox make files and Docker Compose files. And you can try this out for yourself.
All right. Thank you, John.
Can I ask a question now? Or,
we'll save time at the end, for sure.
All right. Hopefully this works. All right. So we are not claim to be the first one to come up with these ideas and the solutions. I know big efforts, and the people have done quite different ways. And why our approach is better is we learn from their ways. And if you are looking at the involvements of the Cinder as the plugins for Kubernetes, there are at least 2 attempts in the past. And one is that a gentleman from CoreOS, Quinton, if I did not pronounce his name, he made one of the first attempts to implement the Cinder standalone driver and for Kubernetes. So the idea is that instead of use the in-tree cloud provider, which only works for one cloud at most, you can have the options to use a standalone Cinder driver, which has the option to give you access to multiple OpenStack cloud providers. And so you are not coupled to the in-tree cloud providers. The momentum that PRs has gone up and down for a while and eventually gets closed because some other approach works. And the second approach, which somehow we borrow from it, is called Stack Cube. It's one of those OpenStack projects. The goal is to have the Kubernetes integrate with OpenStack in its own way. And one of the focus is the flex volumes that will provide the similar service, presents a block device to the Kubernetes and covers the block service from the Cinder. The downside from that idea is that you have to install the flex volume and one of those plugins, which is, in many cases, you may not be even possible to do it. So our approach is really to focus on what Cinder does best and what Kubernetes provides to you. And we don't break any of these of their realms. So they can work as their own way, and nothing will change. So what we have right here, and we just add a new component called external provisioner, Cinder Provisioner. If you go back to a few slides earlier, that's how the things works. And what's missing on your side, this right corner is the provisioner. So we're going to talk this in more details. But what happens here is that everything works as they are right now. You still have this Kubernetes running. You can have the Cinder service running behind. But you don't have to run its own VMs. You can run its own bare metal machines. And everything will just work normally. And this is how the external provisioner works. So if you are familiar with how the dynamic provisioning works, and the sequence happens this way. So you have a standalone external provisioner running as a process or running as a container. The provisioner listens to the API messages or events, rather than objects. So whenever a new PVC created, that gets loaded into SDD. PVC here stands for persistence volume claim. It's a request for storage volumes, and then this event gets caught by the provisioner. Oops. And the request will consist of such information and how much storage space you want. It's 100 gigabytes in this case. And what's the access mode? If you are familiar with the Kubernetes terms, you have read, write many, which usually map to a file shell like NFS, and read, write once, which is usually mapped to the block service like a Cinder. And if we find out this our block service can be provisioned, then we just take this request and go into the next step. Right. So the provisioner take the request and run some of the backdoor magics. Essentially, it's equivalent to what you are using the CLI command, Cinder volume creates. But in fact, we are using the SDKs, the Golang SDK to accomplish the same thing. Why we cannot use the CLI? We're going to cover that in the next slide. So we create the volume and get the volume ID. And with this volume ID, we can do something magical. What?
It's the wrong way.
Wrong way?
Yeah.
OK. I said something magical, yeah. Time flies back. Right?
There you go. You're good.
Good now? OK. So the next thing is once we get the volumes, and if you're familiar with the Cinder API, we can have certain things happen. And it's one of those is just reserve the volumes, which is equivalently to the database operation to reserve the volume in the database, make sure nobody else will take it. And then, come on, yeah. And we get the connection information. That's the magic we are talking about. So the connection information gives you enough details about how the host will talk to the storage, be it iSCSI or Fiber Channel or RBD. This connection info will give you detailed information. For iSCSI, you will get the target portal and the IQN and the LAN. For RBD, you get the image, the pool, and for Fiber Channel, you get worldwide name and LAN, things like that. And these are the information. The OS brick will just make a connection from the host to the backend. So with this information, everything goes naturally in the Kubernetes world. So if you are familiar with the Kubernetes already have native support for iSCSI, Fiber Channel, RBD, and a bunch of others. If you have problems, blame me. So this Kubernetes does not have OS brick library, but what these native plugin supports, just make the connections, make them mounts. That's essentially the same thing as OS brick. So Kubernetes acts as its own Nova, but without have to have the OpenStack installed on it. So from these points, everything becomes naturally in the Kubernetes world. And we have the PV, which maps to the physical volumes in the backend, iSCSI, Fiber Channel, or RBD, and maybe even more in the future, with your good help. And then the Kubernetes part will just use that volume without any knowledge where it's come from, how it gets connected. As long as that is a mounted blocks file system, then it's happy with that decision. Let's see, can I move on? All right. All right, once everything finished, the attached information will be set in the database. So this volume becomes occupied, and nobody should use it anymore. All right, current status. We will not be here without the help of Adam, who's really a good engineer in Red Hat, and he can make all this happen. The project is finished. It's already in the Kubernetes incubator, external storage repository. And if you want to try it, there's good videos and good documentations how this can be used. It's pretty simple. All you need to is to run a container, and the provisioner runs inside the container, and that is run, give the OpenStack config, and this will just automatically make things happen in the background. And the front end, the part can use any volumes, and that is provided by the backend. We have tested iSCSI and RBD, Fiber Channel. So if there's any other block volumes that's supported in the Kubernetes world and also in the Cinder world, then you can also use it as here. We started from iSCSI because iSCSI is the most widely used backend fabric. It's supported by most of the volume drivers in Cinder. And we have the RBD as well. There's a little bit with RBD, but most things works pretty well. For us, we haven't tried it yet, but there's a good project called the TCMU runner. I talked about last year. So you can potentially use it, TCMU runner as a bridge to convert the file to the block device and present it to the local host, just the way you are seeing the QEMU presents the files to the VMs as a block device. All right. Let's jump to hand this over. Okay. And we'll.
So just to kind of try and summarize kind of what we're talking about, because there's a whole lot of stuff going on here, right? And you may or may not be familiar with it. But the gist of this whole thing is basically what we're doing is we've got a external Cinder volume provisioner that will talk to a Cinder deployment that will then communicate with a Kubernetes deployment. So this volume provisioner is external to the Kubernetes tree. So it will have its own repo, it will have its own life cycle, so updates and everything else, which is everything on the plugin side for storage in Kubernetes is going out of tree. So we're going that direction. But the beauty of this is basically all of the maturity and features that you have in Cinder, including things like QoS, volume types, the ability to choose different types of volumes, some of the scheduling functionality, that will all now float up into Kubernetes as well. So I think with that, if there are any questions anybody wants to ask, I don't know, Sergey? So to be clear, when I say Cinder All-in-One, actually, I don't think I said Cinder All-in-One, but it's a standalone Cinder. Yeah, so that standalone Cinder is actually comprised of 4 or 5 different containers. So there is a MariaDB container. So there is a Docker Compose file, and it will launch a MariaDB, a RabbitMQ server, a Cinder volume server, a Cinder API server, and a Cinder scheduler server.
I think that's something you can make it happen.
Yeah. So the trick on that is making that actually run Cinder against that. There's actually a little bit of, it's kind of a heavier lift, I think, and maybe we can talk about it if you have some ideas. But
so once you provision the volumes and it goes to the
So,
Not to make any changes, but as long as it's presented, it's up.
yeah.
Use the Kubernetes container. You might not do any changes, but it's still going to be up.
Technically, no. But on the other hand, there's also no reason to take it away, because if you do send a delete request, then you'd have to make sure.
If you have to do an upgrade or if you have to add features to the Cinder instances,
Right.
then for that short period of time, you do not have those services available.
Correct.
What happens to deploy?
Well, the nice thing is if you go down the path of like the block box method or a cola or one of these other things, that kind of alleviates some of that upgrade problem and that downtime on the upgrades, because now you can actually upgrade in a matter of seconds instead of an hour or whatever. And Cinder actually is significantly easier to upgrade than some of the other projects in OpenStack. We're not doing as much stateful things. We don't have as the high frequency of requests, right? By the nature of persistent storage, it's not like instances that are constantly coming and going and things like that. So, but.
Remember, Cinder's not the data path, so that connection doesn't go away.
Unless you use LVM with the iSCSI target.
Yeah. Also add to the, I just add to John's points. You keep the Cinder running, and that's another benefit. Kubernetes, just for example, it does not have all these Cinder features, snapshots, clone, and migration, backup. And with Cinder, you can do all these things in the background without having to wait for this feature to come to Kubernetes, right? So we are still waiting to get the snapshots on iSCSI fiber channel, and there's no solutions so far in Kubernetes. But with Cinder, that can be done smoothly, and this has been practiced many, many times. So if you want to have snapshots, you can just do it on Cinder and don't have to wait for the Kubernetes to come up with these solutions.
You can even turn on Cinder's replication and use that. So you have Kubernetes volumes that are being replicated.
Yep.
So with the standalone Cinder without Keystone or anything like that, can you still have multiple Cinder volumes and the scheduler will still schedule them to the various Cinder
Oh, yeah, yep. So now the no auth without Cinder, I will be completely upfront. It works, I use it, I do it with all kinds of stuff. I don't know of anybody else that uses it. So, you should try it and definitely let me know if things are broken or things don't work.
But the recommendation would be to use Keystone if you wanted to.
Well, I think in a production environment, most people want some kind of auth and security. And so, yeah, I would probably use it, at least for now, so in a production environment.
Yeah, I think that's a very good point. You can do that way. It's certainly for your own production, but we don't really have any restrictions. As long as it's running and can be accessible, have its own endpoints, the Cinder endpoints can be accessible by the provisioner, we're all good. I think that is a very interesting use case, and actually that is actually a good strength of this core architecture. You could have standalone Cinder. You could also have real OpenStack setup. Nothing will break, and they're still working the same way seamlessly. You could have your own standalone OpenStack setup with Cinder and backend storage, and you can have another cluster, whether that's Baremetal or not. You can have the Kubernetes cluster access the Cinder volumes without any problems. The Kubernetes can. You could either way.
You could do it either way if you wanted to.
Yeah, the provisioner, you could have two instead of just one. In this the presentation we have here, you have the provisioner just against your standalone Cinder, but you can also have the same provisioner or different provisioner running against your OpenStack Cinder.
So,
Yeah, that's
right. But so you would actually have two separate Cinder deployments, right? You could actually, though, deploy a OpenStack on your pods in Kubernetes on top of this and point it to the same Cinder that you're using here. You could do it either way. It's possible, and you can do that, and it actually would work fairly easily. The problem is it'll make your head explode if anything ever goes wrong and you have to fix it.
That's a good point. So just back to Anger's presentation yesterday, I went to your presentation. I think you have at least 3 issues with the current Cinder and OpenStack's integration. One is that the cloud provider is in tree. In this case, it's also tree. And the other one is you have to run this. There's a bug over there. The Cinder volume bug, the V1, V2 detections, things like that. Once there's a bug inside the tree, they have to be fixed in the tree. But with this solution, there's no Cinder anymore. So that's why it gets resolved. Yeah, so at least that's going to be a better experience and easily fixability in terms of issues and the integrations.
The other thing you'll find that's kind of nice about this model, too, is if you wanted to make your own changes and modifications, it's much, much easier now with a standalone service component than with the whole stack.
Yeah. And if you don't want to run OpenStack, which I think can make people unhappy here, if you're like a storage company like Knowoff, you can just have your own software-defined storage right in place with Cinder as a best experience for the end users.
And this is actually something that we use in our lab, is a standalone Cinder. Just to do storage, even without OpenStack.
The only real limitation of this approach, like all those great things, the only real limitation is you're not actually doing a VM. With this approach, you're falling back to doing some remote disk access protocol that I certainly have used. Whereas the in-tree one, because it's also got code running in people, it can do the actual attachment.
This will actually this will do the attach as well.
Yeah.
Yeah.
And another point.
There's no Nova, but, well, so what I'm saying is if you're running Kubernetes and you plug Kubernetes into this standalone Cinder service, what it's doing is it's just using the Kubernetes iSCSI attacher, if it's iSCSI or if it's RBD. It uses that attacher and just attaches it to the bare metal and then does the bind mount just like you would expect.
Yeah. And the other point is, as John is already doing this thing, so as we are moving along to get everything out of the tree in the container storage interface, you don't have to rewrite everything, right? So you don't have to rewrite your iSCSI plugins, IR5 channel plugins. Everything is managed by Cinder. So you get the same experience, and your driver will just work.
So are you just using the black box to deploy this? The standalone environment?
The standalone Cinder environment, yep. So inside of the Blockbox directory in the GitHub repo, the Cinder repo, there's an Etsy directory and a cinder.conf file. All the files are there. So, yep. Yeah, it's awesome. You should check it out.
Cool. Thank you.
Anyone else?
All right. Cool. I think that's it.
Well, thanks, guys. Appreciate it.